will configure and compile Uboot and integrating a standalone application with Uboot. Previously, in the laboratory experiment 1, that is a 2, what we have done is we have created a standalone application. That is to print the hello world on the screen using a QEMU emulator. Why? Because we don't have a versatile PB board. So here also we are using the same QEMU emulator of a versatile PB board, but directly executing the standalone application. First, we'll configure our bootloader called Uboot for the versatile PB, and then we'll compile that bootloader. So upon that, we will launch a standalone application. So that is, previously we have done only a one standalone application, but now what we are doing, we are configuring and compiling a bootloader called Uboot. Once it is done, upon that we'll run a standalone application. For doing that, we have to go for the QEMU. So in that, I want a particular Ubuntu version. So for that, we'll use OnWorks QEMU. So when I go for OnWorks QEMU, you will get QEMU ARM. So remember that if you are working for the QEMU, you should use a Ubuntu 16 version, that is OS Ubuntu 16.04 version. And I'm going to start this. It takes some time for OS to start. Until that, we'll see what is happening here. So you are supposed to download the Uboot from a particular path, and then you have to install the toolchain for that ARM architecture by using gcc-arm-none-eabi, and then you have to install QEMU system. Since it takes some time, we'll wait for it. Okay, so the OS starts. Now open the terminal, create a one particular folder. Okay, next, first I am creating a particular folder, mkdir with your USN, enter into your USN. Okay, then download a particular file. So how to download a particular file? What file you are supposed to download? You are supposed to download Uboot, that is to configure and compile your file. So how to download? This is the path. So if you want to download it, you can use wget directly. Wget is a command to download from a particular link. So what is the link you are supposed to give? ftp:/ftp.x. Okay, this is a path. In this path, which file you are supposed to download? You have to download. Be careful, you are supposed to use the same version. You are supposed to use a same version, Uboot 2010.03.tar.bz2. Once you got, you just wait for few minutes. It will get downloaded from this link. It takes some time to download. Until that, what we can do is, in another terminal, we'll try to install a toolchain. So how to install this toolchain? Which toolchain you are supposed to install? You have to install GCC ARM none EABI. So I'm going to install that now. Sudo apt get install GCC -arm -none EABI. In the previous, we have installed GNU EABI. Now we are supposed to install none EABI. Password 12345 6. Okay, it's done. I'm just clearing the screen. Next, we are supposed to install QEMU systems. So we'll do that. Sudo apt-get install QEMU-system, SYSTEM. Okay, so this is done. We'll check whether it is downloaded or not in the another terminal. Yes, it is. Okay, network is unreachable. We'll try again, or we'll check whether the link is properly given or not. ftp:/ftp.denox.de/pub/uboot hyphen 2010 03.bz. Okay, we'll try it once again. If that doesn't work, I'll give you one more link. Okay, it is getting slow down. I'll give you one more link. Another link is mirror.cyber.bibs.eu/uboot. Okay, so here we'll go with http p:/. Okay. See, it is got downloaded. Now, if you just give ls, you can find this file. So I will just clear the screen and I'll give ls. So you have this file. Now you have to extract this file. How to extract the tar file? By using tar command, tar-zf, and then the file name. Okay. Now if you give ls, you can see that there is a folder which is extracted from a tar.bz2 file. So we'll go into this folder, cd uboot. Okay, now if you give ls, you can see that there are so many files which is available over here, which is related for your bootloader. You can see that there is a drivers, there is a board, okay, there is a make file which have a set of commands. Okay, so there are all other files which is supporting to the bootloader. I will clear the screen. Next thing is, I have to get into a particular folder and then I should say that I'm using QEMU. So where you're supposed to go? cd. Okay, I have to edit that file. So I will type nano space include configs backslash versatile.h. Okay, inside that, be careful under a particular line, that is under config underscore arc underscore versatile, you have to type define config arc underscore versatile underscore QEMU and then exit. Control X, Y, exit. Next, once it is done, then what you have to do, you have to build your file. How to build a file? By using this command. So what is the command? It is make make versatile pb underscore config is architecture you are using is ARM and the cross compile is equal to ARM hyphen none hyphen EABI. Very important. When you're giving EABI, you end with a slash. What is this hyphen says is you are not only compiling only the main tool chain, but you will also compile the sub tool chains like AS, LD, GCC, everything which present after this hyphen. So everything you are giving it for the cross compile. So this hyphen is very important. Once you give this, Okay. 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 The command is wrong. It is versatile PB. Once it is done, it has to say configuring for versatile board. Variant is 9PB26EJ-S. If you remember, for the standalone application, we have given this. Once you build your bootloader for versatile BB, then you are supposed to compile it. How to compile? By giving make all and architecture is equal to ARM and cross compile. It is a case sensitive. Cross compile is equal to ARM hyphen none hyphen EABR hyphen is very important. Give enter. Okay. Once it is completed, be careful. You should not get any errors over here. And finally, it creates a bin file, that is binary file of the bootloader. So you have a raw Uboot downloaded. Then you will build it for the versatile PB and you are compiling it for the versatile PB. Once you have done, you will get a binary file called uboot.bin. So if you just clear and give ls, you can see that there is a uboot.bin file is being created, which was not present previously. Now what we will do is we have done, we have compiled our bootloader. Bootloader is ready now. Now we'll create a standalone application. How to create a standalone application? By writing three files hello.c, startup.s and linker.ld. So we'll do that. So in the hello.c, you have already done this program. So I'm just writing this and find int start const. Okay, so your hello.c file is done. Next, startup.h. Okay, startup file is completed. Next, we'll go for linker.ld. So linker file is done, Control X. Next, how to compile and create a binary file. So the steps are given here. So ARM none EABI. Previously you are using GNU EABI, but now you are supposed to use just ARM none EABI, ARM hyphen none hyphen EABI GCC hyphen C hyphen no ST standard library. Next, the CPU hyphen MPCU is equal to your versatile PB board series 926. And then you are converting hello.c file. That is, you are creating an object file of hello.c file. Unrecognized command line n. Okay, so the problem is the command n CPU. Okay, there is an error. So what is it says? Not equal to colon file. So what was the error you are getting? Expected closing bracket before exclamatory mark. Okay. Okay, the problem resolved. So another one problem, hello.c. Here you should have one semicolon. The second problem is also resolved. Now we'll do assembly. ARM hyphen none hyphen EABI hyphen AS hyphen MCPU is equal to ARM 926 EJ hyphen S hyphen G startup dot S hyphen O startup dot done. Next we'll do a link hyphen none hyphen EABI hyphen LD hyphen capital P linker linker.ld hello.o startup.o hyphen o hello.elf. Linker error at the line number 6. We'll see what is an error. So can somebody identify what is error? Yeah. So the error is I should open flower bracket. Okay, undefined stack underscore top, which is present in the starter file. So stack underscore top. So what you should get sp comma stack underscore top ldr sp. Okay, this is correct. Then the stack I'm using may be wrong in linker file. Okay, see, I haven't added this line. So stack stack underscore top is equal to dot semicolon. Now you run this. Okay, the problem is now resolved. Now we'll create an executable file none eabi hyphen object copy hyphen capital O binary hello.elf space hello.bin. Okay, so here hell.bin has been created, but you may face a wrong, so I'll create a hello.bin file only for. So once it is done, then what we'll do is we'll combine our Uboot file and we'll combine a Uboot file along with a hello.bin file as a flash bin, and then we will run your hello file using a U-boot loader. So how to do that? First we have to create an image from your hello.bin to hello.u image. So mk image hyphen capital A hyphen C none hyphen capital O image hyphen capital P kernel K is a small kernel hyphen D test dot bin hyphen A address should be correct hyphen E hello dot uimg is currently not installed, so you have to install uboot tools. So how to install? Just give sudo apt hyphen get install uboot hyphen tools. Okay, it is got installed. Now we'll execute the command. Cannot open test bin. Sorry, it is not test bin, it is hello bin. We have created hello bin, right? So you are supposed to give hello bin. Yeah. See, we have created an image uncompressed ARM Linux kernel image, which is of 138 bytes at a particular address. Next, we'll concatenate our boot image, that is a uboot dot bin image and hello dot u image as a flash dot bin file. So now it is done. Now we'll see where is actually this flash bin is being located. So for that, printf port bootem is 0x percentage capital X slash n double quote space dollar expr dollar stat hyphen c. Be careful with the spaces also. S u boot dot bin close plus 65536 close. Okay, there is an error in that is a syntax error. I'll just check out. We have got the address boot m0 cross 24d7. Be careful that the printf boot m, this line, everything is a case sensitive and the space sensitive, so you should type accordingly. Then you will get this result. That means your versatile PB standalone application is reside in 0 cross 24d7. Once it is done, you have to give QEMU system arm -m versatile PB -m 128 memory -kernel flash bin no graphic. Then you will get a it will ask you, it will stop in this moment, that is versatile PB ash. So in that you have to give boot m and the address 0 cross 24d7. Where you got this? You got it in the previous command, that is where you try to print the address where your uboot bin file is resided, that is 0 cross 24d7. Once you give that 0 cross boot m 0 cross 24d7, you will get the hello world that you have typed in your hello.c. I'll just show again. Control A, Control X. I'll exit this by using A, X. So if I just give QEMU, you will get this versatile PB ash. Here you are giving boot m 0 cross 24D. What is an address? 24D7. You will get the result. So if you want to exit, you just give Control A, long press, release, then give X. So if that doesn't work, you can directly close this terminal. Okay, so now I will just tell